All new high definition machine learning goodness here on Machine Learning Basics.
Trouble seems so far away, but I don't know your name yet. How hard can it be?
Hey everyone, Blake here. And I know it's been a while since I've made a video. Work's been really tough. Things have finally slowed down after a couple of months of hard crunch time, so I'm back making videos. I thought I'd start with something I've been working on for a while, so I'm using the high definition render pipeline to create a very nice looking scene. So I'm going to go ahead and hit play here. And this is me versus a bot. The bot is on the left, I'm on the right. And as you can see, we have these wonderful shadows. The whole thing looks very high end. And we're using assets that came with the high definition render pipeline example that Unity developed. As you can tell, we're also working on a simple ping pong game that I'm calling Pongo. And so this is a test bed for, again, getting back into some of the basics with the new versions of machine learning. And then it also lets us experiment with multiplayer and kind of a versus systems. So as you can see, we do have some results. So we have a player here that's okay. They're not great, but they're not awful. And that's actually a really good place to be because it's easy to write like a heuristic or something where you're creating a perfect opponent. And a lot of times when you're making a game, you don't want to have a perfect opponent. You want to have a challenging opponent. In this case, this guy isn't super challenging, but I think with just additional training, more iterations, it would probably get to be an even better player. It took us a while to get here. So I'm going to do this video in two parts. The first part, I'm going to give an overview of everything that went on, and I'm not going to go super into a deep dive. That'll be the second video where I go through and I show all of the code, but in this case, I want to do kind of just a lessons learned, right? Here's how I went about it. Here are some of the things that I learned along the way, or some mistakes that I made along the way, because I certainly did make a couple. And so I'm going to go over all of that first, and then in the second video we're going to get in there and we're going to do a tour of the code. So the first one, so when I first started working on this system, I had a game in mind. I wanted to do again the ping pong type game, and so I said, you know what, I always say start small and then build it up, but I really want to make it gorgeous end to end and have all the bells and whistles and look super nice, and so I'm just going to implement the entire thing. And I knew better, and I knew that I knew better, and I did it anyway. I'm not really sure why, but I did, and that of course was a mistake, right? You start with a minimum viable product and work your way up. That's what we did with the lunar lander. That's what I should have done here. But it's Pong, it's an easy game to implement. So there are some things that I did implement a little bit differently, but again, I ended up undoing some of them in order to turn this into a problem that was much easier to teach a machine how to play. So the first thing, I have the scoreboard here, and I have all the nice lighting, and everything looks great, and that was fun, but that's also just extra computation cycles for when you're training. Now that said, it is good to have if you change the scale or shape of some of your objects in your game. That can change your gameplay, and therefore if you train on one set of shapes and then you try to change that to polish things up and make it look really good for a game, and you have another set of shapes, that means that you may have to retrain, or you may have problems training. So there is something to be said for having some of the stuff finalized. That said, I didn't need to have everything quite this polished. So again, minimum viable product. We've talked about it before. I should have paid attention to what I was teaching, and I didn't. So there you go. I too am human and make these mistakes and get a little over exuberant about what I'm working on. As you can see in the scene, this is actually almost all completely the default high definition render pipeline asset. So if you've played around with that at all, you should be familiar with this scene. If you haven't played around with high definition render pipeline, it's still in beta. I think, I can't remember if their exact term is early access or beta or whatnot, but it's still not quite ready for prime time. But the visuals I've been getting out of this render pipeline are absolutely gorgeous. I cannot recommend it enough, so long as your target platform is going to have the processing power for it. But yes, I've been very happy with some of the out-of-the-box performance I've gotten. Some other things that I wanted to do with this is I wanted to make it a player versus player kind of game, and I wanted to do player versus player training. A couple of notes on that. One is I'm not always convinced that player versus player training is going to yield you great results. And people like adversarial systems and like training systems against themselves to see if they can learn new strategy. And we've certainly seen this with things like AlphaGo. What's interesting about that, though, is there is a certain level of competence that you need to build up to in order to play the game. And the first couple of times that I trained this, I had a real problem. And I had a problem for two reasons. One is when I'm training two agents, it takes twice as long as training one agent because it's doing, at the very minimum, the twice number of calculations. But I think that there's also some overhead, so it takes more than twice as long to train two agents. You may hear my dog in the background. I'll post some B-roll of my dog. He's currently chilling next to me. So as I'm training, I have a larger amount of computation, and so it's longer before I see some results and then can make some changes, because I did have a bug that was a very important bug, and I'll get into that in a little bit. And so finding those bugs and resolving those bugs was hard, but at the same time, when you have a game like this, and neither player is that good, then you're not really learning any lessons about how you're winning the game, because you're not playing against a really good opponent. And so this is one of the places where imitation learning is very good. Unfortunately, we can't imitate learn to start off with and then kind of pick up and carry on yet. I know some people are talking about that, but that isn't capability that's baked in yet. So, I had a struggle when I was first trying to train it, and one, I was having issues with bugs, and I wasn't quite sure why. And then two is because neither player was that good, it wasn't giving me a good result. And so I'll talk more about some of the things that you can do to overcome those hurdles to get effective training to get a good result. So the first thing that I did was I had to simplify. So I had done the whole game, and it was up to a score of 7, right? And so the episodes were super duper long. And part of the problem with that is that the system doesn't learn as quickly because there's so much time between episodes. It's not sure what actions did and did not yield a positive result. And in some games, that's just the nature of the game. In the case of this kind of game, however, really I wanted the opponent to focus on not so much winning and scoring, but much more about not losing, because then I could make the episodes very short, and that I would end up with a competent player who is trying very hard to not lose, and then it kind of becomes an endurance thing. By not losing, it increases its chance of winning. So I needed a perfect player, and so instead of, first of all, I also needed to reduce my episode length. So the first thing I did was I just reduced the game from 7 points just to 1 point, right? So you're playing, and then as soon as a point is scored, the game is over, and then you learn from that, and so that the learning iterations happen much more quickly, and the rewards aren't as sparse. And then, so the second thing I needed was a perfect player. And you could create a heuristic for this kind of game, but you might not quite get a perfect player. And I was thinking about that problem, like how do I get a really, really good player so that the machine is learning against an opponent that it basically can't beat, and so that it learns to be as good as it can. Now, we're not using imitation learning, so it's not trying to mimic the perfect opponent. It's just trying to survive as long as it can against the perfect opponent. And so I realized that the perfect opponent in this case was a wall. You can't win. It's as simple as that, right? So now you have your paddle, you have your ball, and instead of playing quite the same game, it's just playing against itself and trying to survive as long as it can, and then sooner or later it's going to lose. It's going to score against itself, and it's going to lose a point. So let's see if I have this on the right brain. So I'm going to take a look. So the left paddle is always going to be the computer. And yes, I believe that is fixed, right? So here it is as the initial set of training was, and this is the computer playing against itself, and it would do this. And again, as soon as it scores against itself, it gets 0 points. Now, I also have, and this is very important, and this is going to lead into that bug that I was talking about, I have some randomization code. I'm using the physics engine to control the ball as opposed to allowing just having a fully algorithmic way of controlling the ball. I'm letting the physics engine take it. So I'm adding some randomness. One, I'm doing that to increase the depth of experience, and then the other reason I'm doing that is because you'll see sometimes that in one direction, exactly, perfect example, one direction zeroes out and then it just goes straight and you could get caught in a loop forever, and so I wanted some randomization to prevent that from happening. And that randomization makes this game a little extra hard because the ball has a little bit of a mind of its own. If I were going to make a real game out of this, I'd probably tweak that a little bit so it's a little more acceptable to the players, because every now and then you're playing the game and the ball does something really weird and it feels strange and it isn't great, but it's certainly good enough for this machine learning example. So we're playing against a wall. Let's talk about that initialization issue. So one of the problems that I was having was I was training the algorithm, and actually I will show you what it did. Let's see here. I think that is going to be the proper brain. See what it does. Yep, there it is. Oh, nope, that's a much better brain. That is not the brain that I thought it was. Let's see here. Do you want to explore? All right, let me take a look. I have a brains folder. I like looking at my brains. Single player, 1. Right, multi. Okay, that's right. I had to go up to the multi before I figured out what the heck my problem was. So multi 2.0 bytes. There we go. Left brain, and then this was trained on a multiplayer, so I think this needs to say left brain in the graph scope. So if you train more than one brain at a time, you have to tell it what brain you want to use. This file may not have needed that. There we go. So this is actually much better behavior than I was expecting. Oh, I'm sorry, I read these files backwards. All right, single player 2.0. All right, left brain. There we go. Now we need a graph scope. Okay. It doesn't like that brain at all. All right, well, I can't seem to find the right brain. I may have accidentally deleted it because I did have some problems with it. What was going on, and I'll show you the behavior. I will use a properly working brain. And I did leave in my game objects, in my game manager, sorry, in the ball, I have the show broken behavior. So what was happening is the paddle was always going to the top of the screen. No matter what I did at the beginning of every game, the paddle would go to the top of the screen, like that. And then it would never go down, it would always just stay at the top. And what was going on was that my initialization was actually flawed. So originally I thought I had written code to randomize the start position of the ball. And no, sorry, not the start position, the start velocity of the ball. What I had really done, wrong one, scenes. Yeah, I'll go ahead and save that. So what I had really done is created the game, and so I said, because I was using the physics engine and I wanted to speed the ball up, I had some logic in there that would take the sign of the ball and then I would just make it go more in that direction. So if it was moving positive in the X direction, I would just add more X to it. If it was moving positive in the Y direction, I would add more Y. Likewise, if it was moving negatively, I would increase the amount of force in the negative direction so that it would go faster. And at the very, if it was 0, I didn't do anything special. And there was my problem. Because I was starting off the game and the ball is at a standstill when the game begins, it always got positive motion in one of the axes. And so the the paddle learned that it knew very, very shortly that the first place it had to go was at the very top, because the ball was always going to be going up no matter what. And because the ball always started going up, even though the rest of the game had the ball, bouncing around and going in other directions, it learned so steadfastly that it's going to start going up. That's all it ever really learned. And that was a really big problem, right? Because I would just start the game and then the paddle would go to the top of the screen and there it would sit. And so the ball would bounce once, sometimes off of it and sometimes not. But it got enough of a reward that it found a local maxima. It found a localized maximum value, and it never learned anything else because it was so focused on making sure that it got that one hit at the very beginning of the game. So as soon as I fixed that, right, as soon as I went in here and I added a bunch of extra code, and so I just kind of left this on so you can see how, if I hit show broken behavior and play this game, right, it always starts up. And I didn't catch that for a long time. Like, I went through a number of training cycles. I could not figure out what was going on. But here we are, as we're playing, we can see that it's always starting up. Sometimes it's left, sometimes it's right, but it's always up. And so that was enough that the ball, or I'm sorry, the paddle learned always has to go up. So once I resolve that behavior, right, and so I'll uncheck this so that I'm no longer showing the broken behavior. Once I was able to resolve that behavior, I got much better behavior out of the thing. So I thought it just wasn't learning and the training was going wrong and I couldn't figure out, maybe I was passing some bad parameters or having some other issues, and it was just a lack of good randomness as during initialization was causing my training to have some very significant problems, and I was stuck on that for a while. So when in doubt, go through, double check all of your initialization stuff, make sure things are randomizing the way you feel they should, because that's really important for training, because otherwise, again, you might get just caught in a local maxima at the very beginning and never get your way out of it. Okay, so we've seen single player against a wall. So this is the training environment. So once again, I was hoping that Pong would be a simple enough environment that I could just have one game running for long enough and no, parallelize this stuff, right? And in this case, I just created one scene, prefabbed it, and then duplicated it. So I didn't even bother with the scene duplicator. I just manually created a prefab, made multiples of it, and let it go to town. So this is part of what I was talking about when I was doing the training, is all that beautiful scene stuff is gone, right? This is the heart of the game. It's happening on a 2D plane, and this just saves CPU and GPU power when I'm training, and a lot of times, I make sure to minimize the windows so that it's not actually drawing to the screen. I don't know for Unity if that actually speeds it up, but I do also combine windows so that it's not rendering both a scene and a game window, because I know that does make a difference, and then I try to shrink it down, and then I just move it off. I minimize it, get it off the screen. And that just helps reduce CPU. In a game like this, it's probably not going to make a huge difference, but it's a good habit to be in. All right. So once I got the game running, I actually trained up this one first. Silly dog. I trained up this one first. And this is the one that you've been watching me play. I only trained up the left paddle because, again, when you're training both the left and the right, it takes twice as much CPU. Now, if you are clever with your math, you can set your observations so that it's all based on the perspective of your paddle, and then you can actually use the same brain for the left and the right. And that crossed my mind, and I thought about doing that, but at the same time, I wanted to see if I could get some different behavior in the left and the right. So once I got all of my bugs fixed, I shortened my episode time, I simplified my scene, made multiples of it, so I was training multiple at the same time. I got my initialization bug out of the way. That's when I went over to left versus right training again. And so this is where I ended up. As you'll see, these players are playing kind of. They are playing more than they're not playing, but it's not. It's nothing I would call convincing, right? This is not convincing play in any way, shape, or form. And what I haven't done, and what I probably should do, is have cage match between the two brains. So let's go ahead. So this is left brain versus right brain, right? And here we go. Multiverses, great. And then so for the left brain, I'm going to go into my brains folder. Brains. Pongo, brains. And then I am going to pick the fixed 5 million. Yeah, so I trained them at 5 million iterations. Bring that over there. And I'm going to pit these two against each other in a cage match and watch the whole thing fail. Sweet. Oh, right. This brain doesn't need the left brain graph scope. I kind of wish it would just ignore it if it doesn't need it, as opposed to erroring out. But you know what you're going to do. So both of these brains were trained for 5 million iterations. So they were trained for the same amount of time. The right brain was just trained against another novice brain that was learning, and then the left brain was trained against a wall, so that it was trained against what I would call a perfect opponent. This match is actually, the fact that the right one has scored any at all is a little surprising, because as you can see, the left brain is pretty much dominating the scene. Now, I will say, because with Unity ML agents, you can pick up where you left off. I would be very curious to do a couple of additional experiments, right? This provides us some great opportunities for more multiplayer experiences, such as, oh, there we go. Yep, the left one already won the game. Some additional experiences, such as, you know, now leaving this brain as a in-game brain, and then train another paddle specifically against this, and then kind of increment back and forth and to see where that ends up. Or, you know, we could try versus for longer to see if we come up with anything, or have two of these continue their training from there. This match is a little closer than I thought. No. But again, you can even see, as you're watching them play, one of them is a much more decisive player that's getting a bit less lucky, or who isn't relying on luck as much. The right-hand player is just not as strong. So yeah, again, that's 2 games in a row for the left-hand player. So there we are. That's an overview of what I've been up to and some of the things we've been making. If anybody has any questions or comments, please feel free to put comments below. I will try to get this code up on the GitHub. I am not going to use the same repo as the other lessons. I'm going to create a new repo specifically for Pongo, as I've been calling it. Again, thank you to my patrons who have helped make this show possible, and they've been a big help in terms of keeping me motivated to keep making videos, because it's really nice. Not that the money itself is terribly important to a larger degree, but to have somebody who cares enough about what you're doing that they're willing to put money on the table and say, hey, I'm going to support this because I want more of this content, is it shows a level of commitment and interest that's more than just somebody leaving a comment and saying, hey, I like your stuff, which those help too. Those are nice, but having patrons is really a wonderful thing, and I am grateful for the patrons, and I'm sorry it's been so long since I've had a video. So here we are. I am going to have a follow-up video, which is going to be a deep dive into the code, and we'll just do a tour of the code and see what's going on. So thank you all very much, and let me know if you have any questions, and in the meantime, happy learning.